Welcome, YouTubers, to Finding Primes Between 1 and a Billion. Okay, what I want to do to start out is I want to show you how and where you can download the same program that I'll be running in this video, just in case you want to run it on your computer to see how fast your computer can run it. So open your browser up to bradmccoy1969.com, and when you get to this page, click on File Repository, McCoy Compiler, Executables. The Aratho4.exe is the one I'll be running today. Along with it, you need the runtime.dll. Just download those, and you can run it from the downloads folder, and you'll have the same program that I'm running here today. Okay, the next thing I want to do is I want to show you the compiler that I've been making that's generated this file, and the assembler that was written to create the program. So click on the compiler folder and click on the downloads. The version I'll be running is version 0.5. Click on that. It downloads. I'm going to click on Open when done. And click Run. Click Yes to user account control. And here is my installer. Go next, next, yes, next, next, install. And next, and finish. And over here on my other display is the program. Okay, now from here, what we want to do is we want to read in the program for the primes. That's located here on Import from Internet. And that's over here. Let's bring it over here. It's called V05 Eratosthenes McCoy Archive. Click Open on that. What that was 3 files. One's the VBP file, not much in there. The next one is the assembly that was used to create the program. And the third thing that downloaded in that archive was a runtime.dll, which is located, it got copied to your hard drive on C program data McCoy bin. The program data file is hidden by default by your operating system, so you have to unhide that to see that. The Aratho4.exe will not be there at this time. What you do at this point in time to create the exe is to right click on the project and click on Create EXE. Now when you come back over here, the exe will be there, and the date timestamp that's my time right now. Now what we're going to do is we're going to run the program about 4 times. And here it is. It asks you what's the upper limit. We're going to start with 100. It says finding primes up to 100. Time to create the primes in milliseconds. Nothing, which means it should be 0, I believe. Press 1 to print the primes. I'm going to print the primes this time. There they are. I'm going to press enter to finish. Enter. Program's over. There's the first run. All right, I'm going to run it again. This time I'm going to do 1,000,000. 1, 2, 3, 4, 5, 6. Enter. 31 milliseconds. Pretty quick. I'm not going to print these out because it takes a minute. Press enter. Done. Okay, let's run it again. Drag it over there. This time I'm going to do 100 million. 100. 1, 2, 3, 4, 5, 6. Enter. Oh, that takes some time. Alright. And 8.9 seconds. Well, that's the slowest so far. It's usually around 7.5 seconds. Okay. Press enter, press enter. Now, the last run will be 1 billion. Here we go. Upper limit. And here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. 1 billion. Go. Okay, that's going to take a little bit. I'm going to, while that's running, I'm going to drag that out of here out of the way. And I hear my fan kicking up. It's got the CPUs racing right now. I'm just going to trace the program a little bit here while that's running. I'm not going to get too involved in it, just kind of basic. Well, I got a runtime function called initcmd, which will open up the console window. It runs this, asks the question, what is the upper limit? Then it runs create primes with whatever you type into that box. Create primes is, so I'm gonna show a side pane here. These are my functions in this file here. I'm going to go to create primes. It's a little handier to use that than the page down, up and down. The create primes function will start off by printing finding primes up to, and then print the number. Then it starts a timer. It's a Windows API call called getTickCount64. That's the number of milliseconds since your last reboot of your computer. And it records that time in a variable called start time. Now we're going to request some memory. What it's going to do is it's going to request 1 billion bytes for this run that it's doing. And each byte will be initialized to 0, and a 0 will represent a prime number. So when these loops run, it's going to be finding numbers that are not prime, and then it'll be writing into memory a non-zero value that'll show that it's a non-prime number. If the memory is not allocated, it'll print a message could not allocate, and then return from the function with an error code 0. The first thing it's going to do before it hits the loops, it's going to go through and set every even number to non-prime, starting with 4, because 2 is actually a prime number. You can go down and see that loop as well if you'd like. Then a little lower here, we get into the meat of the program here that takes all the time. This is where it's a loop within a loop that goes through and finds the numbers that are non-prime and marks them off. After it's done doing that, it goes back to get tick count to see what the timer is. Subtracts that from the start time, moves that value in the RBX register. I'm just going to use the RBX register as a way to pass it back to the parent, to the calling parent. And then I use the RAX register to pass success or fail of the function. Then we're going to go back up to the top. It's where we started. We just come out of right here, create primes. And if it's 0, it's going to jump all these lines and go to the end. But if it's non-zero, which means a success, it's going to say time to create the primes in milliseconds, and it'll print out the time it took to run. Then it's going to ask you if you want to print it to console. If you hit 1 enter, it's going to run the report primes function. After it's done doing that, it's going to print finished press enter and free the console, free the memory, and done. Okay, that's how the program runs. Now let's go back. The billion is done. I'm going to drag that on the screen here. And here it is. Okay, it took about 115 seconds to find all the primes from 1 to a billion. This is, I don't know if you consider that slow or fast. My desktop did it in 20 seconds. So this laptop is about a dozen years old, and it's trying to create a video at the same time. So the laptop took longer. So let's see here. My laptop here is a Celeron dual core CPU, 2 gigahertz. So it's not a fast computer. It's pretty old. My desktop is an AMD dual core, or maybe quad core, I'm not sure, like a 3.8 gigahertz. It can do the 100 million primes in 1.6 seconds. The benchmark that I was hoping for is doing 100 million primes in 200 milliseconds. It's because on davesgarage.com he made a video where he said his program